Hi, today I want to talk about an implement of the email spam filter by an automated text categorization. When we talk about the spam filter, there is an investigation that it has been estimated that more than 17% of the emails are unwanted message or spam. There are common types of filters. Treat incoming message according to the previously learned knowledge of the sender, and categorize mail accordingly. So in my import, the methods I used are the BIS and the SVM. And talking about the BIS spam filter, let's suppose the suspected message containing the word replica. Most people who are used to receiving email know that this message is likely to be spam. More precisely, a proposal to sell counterfeit copies of well-known brands of watches. The spam detection software, however, does not know such facts. All it can do is to compute probabilities. So, this is a formula I want to use, and this formula used by the software to determine that it's derived from Bayes' theorem, and I will use it to conduct an algorithm. And about the advantages of this method, I want to talk is the spam that a user receives is often related to the online user's activities. For example, a user may have been subscribed to an online newsletter that the user considers to be spam. This online newsletter is likely to contain words that are common to all newsletters, such as eventually assign a higher probability based on the user's specific patterns. The legitimate emails a user receives will tend to be different. For example, in a corporate environment, the company name and the names of clients or customers will be mentioned often. The filter will then a lower spam probability to emails containing those names. The word probabilities are unique to each user, and it can evolve over time with corrective training whenever the filter incorrectly classifies an email. As a result, in Bayesian spam filtering, accuracy after training is often superior to predefined rules. It can perform particularly well in avoiding false positives, where legitimate email is incorrectly classified as spam. For example, if the email contains the word Nigeria, which is frequently used in the wants fee for a sign, a predefined rules filter might reject it outright. A Bayesian filter would mark the word Nigeria as a probable spam word, but it would take into account other important words that usually indicate a legitimate email. For example, the name of the spouse may strongly indicate the email is not spam, which could overcome the use of the Nigeria. And talking about the advantages, so what's the disadvantages? I think the first is, depending on the implementation, Bayesian spam filtering may be susceptible to Bayesian poisoning, a technique used by spammers in an attempt to degrade the effectiveness of spam filters that rely on Bayesian filtering. A spammer practicing Bayesian poisoning will send out emails with large amounts of legitimate text, which are gathered from legitimate news or literary sources. Spammer tactics include insertion of random, innocuous words that are not normally associated with spam, thereby decreasing the email spam score, making it more likely to stay past a Bayesian spam filter. However, with, for example, the Paul Graham scheme, only the most significant probabilities are used. so that padding the text out with non-spam related words does not affect detection probability significantly. The words that normally appear in large quantities in spam may also be transformed by spammers. For example, Niagara would be replaced with Niagara or Viagra in the spam message. The recipient of the message can still read the changed words, but each of these words is masked more rarely by the Bayesian filter, which hinders its learning process. As a general rule, this spanning techniques does not work very well because the derived words end up recognized by the filter just like the normal ones. Another technique used to try to defeat Bayesian spam filter is to replace text with picture, either directly included or linked. The whole text of the message or some part of it is replaced with a picture where the spam text is drawn. The spam filter is usually unable to analyze this picture, which would contain any sensitive words. However, since many mail clients disable the display of linked picture for security reasons, the spammer sending links to distant picture might reach fewer targets. Also, a picture size in bits is bigger than the equivalent text size, so the spammer needs more bandwidth-wise to send a message directly, including the pictures. So some filters are more inclined to decide that a message is spam if it has most graphical contents. A solution used by Google in its Gmail email system is to perform an OCR, which means optical character recognition, on every mid to large sized image, analyzing the text inside. Okay, next one is about TF-IDF. TF-IDF is a weighting factor used in information and text mining. It represents a numerical statistic which rejects how important a word is to a document in a collection or corpus. The term frequency is a value that represents how often a particular word appears in a document. The more frequent the value of the word is, the more important it is in the document. However, if the word appears too frequently in the corpus, this means that the word is so common in the corpus. For example, the atom would be the key word because it does not appear in normal documents, but it becomes a common word in physics, in which it is mentioned frequently. This situation can be adjusted by IDF, inverse document frequency. The document frequency can be obtained by dividing the total number of documents by the number of documents containing the term. The IDF is the inverse value of DF, and TF-IDF is the product of the two statistics TF and IDF. A high weight in the TF-IDF is reached by a high term frequency and a low document frequency of the term in the whole collection of the documents. Hence, the weights tend to filter out common terms. TF-IDF can be successfully used for stop word filtering in various subject fields, including the text summarization and classification. And these are the algorithms used in the experiment. In this algorithm, we use the score M and a threshold N to judge an email whether a ham or spam. If the score M is greater than N, which means the email will be supposed to be a spam. If not, then it will be a ham. The value N will be garnered by training numerous samples, which will be shown in the experiment section. So after the whole experiment, the environment is is shown in the slides, and the data set we used for training and testing is the sum number of training emails, which is 5,000, and containing of 100 harm emails and 1,000 spam emails. These emails are already labeled by manually and classification as spam or ham, and no encoding in email content. After training, in order to test our algorithm, we used a testing dataset which is made up of 750 spam emails and 150 harm emails. So the evaluation results looks very good, and as we can see in the table, after the iteration by the algorithm, they eventually shows that for the total 900 emails, the precision of detecting spam is 98.93%, which is really high enough to people use in daily life. So the summary of this experiment is that we evaluated the text classification and also implemented the spam filter using Java libraries and Bayes, and we also got the high precision and accuracy results. But the filter algorithm used to continue can be used to continue a deeper study, improving filtration accuracy. And also we can also add audio, video, pictures, and other filtering capabilities, and do not limit it to the mere text filtering. So I think this is the work maybe we will do in the future. And that's all. Thank you.